Today we're going to talk about chromatography and four of these kinds that we discussed in class, which are adsorption, affinity, ion exchange, and hydrophobic. So, what is chromatography? Chromatography is a way to separate a mixture of substances in the lab. When talking about chromatography, it's very important to mention that the immobile phase is a fluid where the mixture of substances is dissolved, and the mobile phase passes through the stationary phase. Now we're going to talk about the overall concept of chromatography on the example of TLC plate silica gel chromatography. So here how it looks like. This is the beaker, this is the TLC paper, and this is our solvent. TLC silica gel is stationary phase, which is here. The whole plate is TLC stationary phase. The mixture apply is this red dot right here. We apply it on the origin of chromatography, which is this line, the whole line. And our solvent is the mobile phase, and this is here, the whole solvent. And origin of chromatography should be above the solvent.
So, over time, the solvent is going to move up our plate, and here's our original mixture, and as it moves up, it's going to take our mixture with it, and the mixture is going to travel at different speeds, which is shown on this paper. And here's the solvent front, and it's going to be moved upwards, and so here is our final plate with our mixture separated out.
In this presentation, we are going to talk about four different kinds of chromatography, which are adsorption, ion exchange, affinity, and hydrophobic chromatography. Adsorption chromatography. First of all, adsorbent is a substance that attracts other substances to its surface. In this kind of chromatography, the stationary phase is adsorbent, and molecules that travel through it are separated due to different interaction with the stationary phase. It's important to note that this kind of chromatography is used only in solid liquid or solid gas phases, because adsorption term relates only to the solid phase. The next type of chromatography is the ion exchange chromatography, which separates molecules based on their charge. Their total net charge is based on the media they are in. So they can carry positive or negative charges, or they can be neutral. Depending on the charges of the mixture to be separated, people use cation exchange chromatography or anion exchange chromatography. This kind of chromatography is commonly used to separate biological molecules, such as proteins, peptides, amino acids, and others. Affinity chromatography. Affinity chromatography separates biological substances based on their interactions with media they travel through. Those interactions may be forming hydrogen bonds or sulfide bonds or hydrophobic reaction. Due to reversible interactions between the protein and the ligand, the protein may be separated on the matrix. So, the last type of chromatography that we're going to discuss today is the hydrophobic interaction chromatography. But let's first define the term hydrophobicity. The Greek root hydro means water, and the root phobia means fear. So together we get fear of water. Therefore, this kind of chromatography separates substances based on their hydrophobic properties, or their interaction with water, and the saltiness of the solution. The hydrophobic interaction chromatography is used to purify proteins without disturbing their biological activity by using less harsh conditions that are less denaturing for the proteins.